Activity 5.3, we're going to determine width indirectly. So when it's not reasonable for you to directly measure the width of something in the real world, you can use indirect measurement. All right, so a group of friends are visiting the park, and Lauren stands on one side of the creek and Caleb stands directly across the creek, as shown in the figure. Caleb's standing 5 feet from the creek, and Lauren is standing 5 feet from the creek. Each friend walks away from the other in opposite parallel directions. Caleb walks 50 feet, and Lauren walks 12 feet. So question A, how do you know that the triangles formed by the lines are similar? So if we kind of create our own little triangle situation here, or little triangle image, it'll look something like that. And then if you think about it, we've got two 90-degree angles, and then we have vertical angles. So we can prove these triangles are similar by angle. Now it says calculate the distance from Caleb's starting point to Lauren's side of the creek. Round your answer to the nearest tenth if necessary. So let's go ahead, and I'm going to sketch this picture again. Make it a little better this time. Okay, so we know this is 50, and we know this is 12 and 5. And so we are trying to calculate x here. So I know that not all of that is the creek, but we just want to know the distance Caleb is from the point where Caleb is compared to Lauren's side of the creek. So we can set up corresponding side length ratios and set them equal to each other. So x is to 5, as 50 is to 12. So now we can go ahead and cross multiply, and we get 250 equals 12D. And it says round your answers to the nearest tenth. So we get D is approximately 20.8 feet. So now, let me box that. Part C says, what's the width of the creek? Well, if I go back up to my picture, the creek is not all of that right there. So we want to figure out, okay, if the entire thing is X, if I highlight that. So from Caleb all the way, from Caleb all the way over to Lauren's side of the creek, all of that is 20.8. Well, in the beginning, we're told that Caleb was standing 5 feet from the creek as well. So we would do 20.8 minus 5, and that would give us what the width is of our creek, which would be 15.8 feet. All right, moving on. There is also a ravine, a deep hollow in the earth, on another edge of the park. Rachel and Gavin take measurements to indirectly calculate the width of the ravine. The figure shows their measurements. Calculate the width of the ravine. So very similar. So it looks like we can set up, again, corresponding side length ratios, set them equal to each other. So it looks like we're going to do, let me use a different color. We want to find this blue segment. So let's call that X. So 6 feet on the small triangle is to X, as 15 feet on the small triangle is to 60. And then what we can do is figure out what X is and then subtract 8. So we've got 360 equals 15x. Divide both sides by 15, and we would get 24. So if the whole thing is 24, and I know that Gavin is standing 8 feet from the ravine, then you're going to do 24 minus 8, and that gives us 16. So the width of the ravine is 16 feet.